Our universe is a huge space that we can observe and explore. Today, the most distant region that scientists can see is the surface of last scattering. This is where the photons of the relic radiation that arose almost immediately after the Big Bang come from. The surface of last scattering reflects the moment when the universe became transparent to radiation. Beyond this region is something that is not yet subject to study by our instruments. We cannot see the region that is located beyond the surface of last scattering because it is opaque to radiation. And so that you can at least slightly imagine the scale of this magnificence, I will remind you that the observable universe extends for at least 93 billion light-years. For comparison, the diameter of a typical galaxy is only 30,000 light-years, and the typical distance between two neighboring galaxies is 3 million light-years. However, there is a hypothesis in the scientific community that there may be many interesting and mysterious things beyond the universe. But before talking about what or who is beyond the universe, it is worth finding out, what is this border? To do this, it is worth going back in time to about 13.8 billion years ago. At that time, our universe was in the state of a very dense and hot object called a singularity. Then there was an explosion, and the universe began to expand and cool. Over time, particles and energy began to combine, forming atoms, and then molecules, from which the first stars and galaxies arose. Observations show that the universe is indeed expanding. All galaxies are located far from each other, and the distance between them continues to change at an increasing rate. But over time, gravity came into play, and the expansion slowed down. However, recent research suggests that the expansion is now accelerating again due to a mysterious dark energy that makes up most of the energy content of the universe, but little is known about its nature. So, we have a singularity, the Big Bang, the expansion of the universe. And today we see the universe as it exists 13.8 billion years after the Big Bang. A singularity, in simple terms, is a place beyond which the laws of mathematics and physics do not work, so there is no point in trying to predict anything. And now it is time to talk about boundaries. However, it is worth noting that the concept of boundaries of the universe may not be entirely correct, since space and time themselves may not actually be what we are used to understanding them. And the size of the universe, due to the inconstancy of its spacetime, depends on which definition of distance you accept. The comoving distance to the most distant observable object is about 14 billion parsecs, which is equivalent to 46 billion light-years, in all directions. Thus, the observable universe can be represented as a ball with a diameter of about 93 billion light-years, with the center in the solar system, where the observer is located, that is, us. It is important to note that the light from the most distant observable objects shortly after the Big Bang reached us at only 13.8 billion light-years, which is significantly less than the comoving distance to these objects, equal to 46 billion light-years, again due to the expansion of the universe. Modern cosmology suggests several options regarding the limits of the universe. For example, a closed universe. In this model, the universe is a surface similar to a sphere. Therefore, when moving in any direction, sooner or later you will return to the starting point. In this case, the universe may be finite, but without defined boundaries. The next option is an open universe. In this model, the universe expands forever, and space is limitless. There are no defined boundaries, and the universe is truly infinite. And there is also a hypothesis of a flat universe. In this model, the universe has a flat geometry, and its dimensions may be limited, but again without defined boundaries. And today the boundary of the observable universe can be set at 13.8 billion light-years. However, this does not mean that the universe ends there. We are simply not able to look further yet. This is related to the concept of the cosmological horizon, a sphere in the universe, the points of which have an infinite redshift. The time it takes for photons from this sphere to reach us is equal to the age of the universe. Because of this, we are not able to see objects located further than this sphere, even if they exist. Even using the speed of light as the cosmic limit, there is a fundamental limit to how far back in time we can look. For example, it takes 8 minutes for light to travel from the Sun to Earth, and 2 million years from our nearest galaxy, the Andromeda Galaxy. If we continue to look into space, we will see events that happened even further in the past. However, this will only get us closer to the edge of the universe. However, there is a catch to physically being at the edge of the universe, let alone seeing it. Once again, it all comes down to the expansion of the universe and the incredibly vast distances. It is impossible to travel to the most distant part of the universe from us, even if you travel at the speed of light, because it turns out that objects that are far apart continue to increase the distance between them at an incredible rate. We need a way to travel faster than the speed of light, which is still impossible, or to somehow go beyond the limits of spacetime, which is also somehow unlikely. So, if the limit of the universe has been determined, then a natural question arises: what could be there if this really is the limit of limits, the final border, the end? Scientific theories about what could be beyond the universe are usually based on assumptions, conclusions from known physical laws and mathematical models. For example, such a mysterious phenomenon as dark flow. The idea of a dark flow was proposed in 2008 in the work of astronomers Alex Kashlinsky and Ruther Emke. Research has shown that some galaxies and clusters of galaxies move at a higher speed than would be expected based on gravitational interaction alone. Based on this phenomenon, a hypothesis appeared that in distant regions of the universe, beyond our observation, there is a certain large volume of matter that has an additional effect on the movement of galaxies. However, it cannot be detected using conventional optical or radio telescopes. It is this hidden mass that has been dubbed the dark flow. Some scientists believe that it may be related to irregularities in the early universe that were left over from the Big Bang. The structures of these irregularities themselves could be anything: a cluster of enormous mass and energy, or portals that conduct gravity from somewhere else. And there is another theory, which I believe is the most likely: there may be something beyond our universe that lies beyond our understanding of space and time. It could be a higher level of reality, where the laws of physics as we know them do not apply. It could be some kind of metaphysical dimension or some other undiscovered scientific phenomenon. Some scientists also suggest that there could be absolute nothingness beyond the observable universe. This means that space and time, as we understand it, simply do not exist beyond our universe. What is hidden beyond the horizon of our understanding remains unknown, like the incomprehensible symphony of the universe. But perhaps it is precisely in this mystery that its endless charm lies. And most likely it is there, in the reality incomprehensible to our understanding, that the one who created our universe lives, the supreme intelligence, the creator, or simply God, that is, a mysterious entity that humanity cannot even imagine in its wildest fantasies. The light of distant stars reminds us that the past is the key to the present, and our desire for discovery and knowledge is the engine of progress and the road to God.